Hello everyone, let me show you generation of a clock pulse using a NAND gate. A NAND gate basically, as we have seen in earlier videos, has three inputs, two inputs and one output. 3 pins are used out of the 14 pins. 7th pin is ground, 14th pin is connected to a power supply of 5 volts. Now the basic principle of a NAND gate here is that when both the inputs are joined together, it behaves like a NOT gate. And it is this principle that is used to convert a simple RC circuit into an oscillator circuit. As you know, RC circuit is basically a pulsating circuit, okay, pulse generating circuit. To this you are using a NAND because you are using it as a switch. 0 means 0 state. When you close the circuit, when a high state is coming in, then it is, when the input is 0, output is high. When the input is high, output is 0. So you are actually giving on-off states. So it's nothing but a square wave generation. So instructions. This is the basic circuit here. You can see this is a quartz. This is a crystal here. This is oscillating. RC circuit is an oscillator circuit. We are using NAND gate as a NOT gate to generate 0 and 1 alternating pulses. Okay, so you are using resistor as a feedback and a capacitor junction to the input. The junction of R and C is your input. Output is connected to a function generator to see the waveform. So let me take the breadboard. All the components. Breadboard has come. A supply, 0.001 microfarad capacitor, 35 kilo ohms resistor. This is your NAND gate used as clock, a CRO to see the wave pattern. So once again, if you can recall the circuit, a feedback resistor is connected between the input and the output. So you are out, basically this is a NAND gate, so the output is this point and your input is this point. And also you have to connect both the inputs together to behave like non-inverter. One end to the capacitor, other end to the ground. And once again pin number 7 to the ground. Okay. Pin number 14 to the power supply, 5 volts to the power supply, negative to the ground. Okay, and it will ask CRO to be connected to pin number 3. Yes. It has 2 channels and we are using only 1 channel here. Yes, yeah. So check the connections. It says the connections are right. So this is how your CRO is coming. Adjust the frequency. Yeah. If you adjust the frequency, you will be able to see the waveform properly. Yes. So R and C values are taken as 3.5 kilo ohms, 0.001 microfarads. Theoretically, the calculation is 1 by 2 pi RC, the frequency of oscillation. Substituting these values, you get the frequency as 455 kilohertz. From the experiment, you see the time period, substitute here, the reciprocal of the time period will give you the frequency and compare these two frequencies. So you can shift, X shift. So from here almost, so now from here to this, yes, from here to here is your time period. So 1, this is 2, 2.2, 2.25. So let me substitute here 2.25. See, this is in microseconds. So 2.25 into 10 to the power minus 6. 444. Theoretically it's 455, this is 444. Repeat the experiment several times and you will be able to get the concurrent results. So this is how an application of a NAND gate as an oscillator. So NAND gate is used here as an inverter. R and C circuits are used to generate the waveform. Okay, thank you.